Hello, okay, today I'm gonna show you how I did the projectile motion experiment. Okay, first of all, we need a plane, and on the plane we need to mark S1, S2, S3. What is S1, S2, S3? S1, the S are the distance for from the launcher. I use 2.5 centimeter, that is 0.025 meter launcher, and then we need I put protector from the side of the plane to measure the angle of the plane, starting from 35, 40, 45, 50 and 55 precisely. And we also need to, in the procedure, we also need to measure the y axis for the plane for every angle. And we also need to mark the S1, S2, S3 on the floor to measure it when we launch the marble. S1, S2, S3, S1, S2, S3, this S1, S2, S3. So this is for the X. When we launch the marble, we start measure it based on the S1 and S2, S3 that we use. So this is how I measure the projectile X. And now let's launch the marble to measure the projectile X distance. So I'm gonna start with, I already set the plane to 35 degree, and I'm gonna, this is the tricky part of the experiment. I'm gonna pull it until S3. So I'm gonna find the S3 value. 1, 2, 3, go. Not that good. We're gonna try again. Oh. So let's try again. So 1, 2. Okay, that's good. So I see the marble first land here. So we take this, we measure it from the start. This is S3. So measure the S3 and measure the S3 of X, and for the Y. After we got the value, we can then find the velocity and the maximum height from the formula, using the formula. So that's why I'm using grass. This is why I'm using grass surface, because it can absorb the impact from the marble, so to make it less moving around. So now there is two equations that we can use to find the general velocity. First equation is from using the time itself. T equal to x minus 0 divide by VO cos theta. VO cos theta is initial velocity for graph X. Okay, the second equation is y equal to 0 plus y 0 plus velocity for graph Y multiply by time minus 1/2 multiply gravity and time square. Alright, this is the second equation. Okay, now let's find the initial velocity for our data. Okay, the first data that we got is for angle 35. Distance for X is 1.11 meter, and height for Y is 0.47 meter. So we just insert X value in time equation. This is T equal to 1.11 meter minus 0 over V theta V cos theta. V cos theta. So this is our first equation. So insert this first equation in the second equation. So let's so it should be like this: y to 0 plus v 0 y time 1.11 over per v v cos theta minus 1 over 2 multiply 9.1, this is gravity, 9.81, and this 1.11 per v cos theta square. So this is the starting for the equation. Now as we can see, VOY equal to VO sine theta. So basically we can enter the equation in this, so it will be y 0, we don't need 0, sine theta 1.11 over cos theta 0.5 9.1 1.11 over v cos theta square. So this still not the full equation yet. As in the basic math, we can cut both of this. Sine per cos equal to tan theta. Sine theta per cos theta equal to tan theta. So we can just write it tan theta multiply by 1 meter, 0.5 multiply 9.8 1.11 per v cos theta. This is for angle 35. Okay, we already got the equation, and we should put that. Okay, let's write new. So this is the full equation. In the data, y equal to 0.47. Alright, so we just put in the equation. So it will be 0.47 equal to tan 35. Why tan 35? Because this data that we got is for angle 35 degree. Multiply 1 minus 4.9005 multiply by 1.11 over v cos 33. When I said before, why 35? Because this data that we got is for angle 35. angle 35. Okay, now let's calculate this. We settle one by one. So tan 35 multiplied by 1.11 equal to, yeah, equal to 0.78 minus, we settle this, all of this, because of the multiply, so we can just direct multiply this. So negative 4.905 multiplied by 1.11 square. So this be negative 6.04 over university cos 35 square. Don't forget square here. So 0.47, 0.78 we move it here. So 0.47 will minus the 0.78. We will get negative 0.31 until 0.31 equal to negative 6.04 over VO cos 35. Okay, so negative 6.04 will divide by negative 0.31. So we will get, so after we divide it, we will get we'll get 19.48 equal to V cos 35 square. So we only want the V, each university. So 19.48 will divide by cos 35 square. So the each university will be 29.04 ms. So 21. So this is the each university for angle 35. So to find another velocity for another angle, we use the same method, but you have different data for the x, for the how far the x and y go, and the head of the y. Sorry, and so right now we already have the velocity, let's say 29.04 ms. So keep that in mind. We have the velocity right now. So the experiment also want us to find the maximum height. So maximum height equal to h equal to velocity of y square 2 over 2 gravity. So we got for the angle 35, the velocity for angle 35 speed 1, angle 25 speed 1, 0.025. The velocity is 29.04. Alright, this is the velocity. So as we know, VOY equal to VO sine theta. Right. So we just insert the velocity in this, and the theta is the angle that we use, that is 35. So the calculation is 29 equal to V, let's say V 29.04 multiplied by sine 35 square over 19.62. Why is 19.62? 19.62 equal to 2 multiplied by 9.1. This is the gravity. So we will get the maximum height is 0.47 meter. Oh my god, 7. So that is the calculation, the experiment. So every angle and every speed using the same calculation and formula, we will get different answer and different maximum height of the every angle and from the different speed. So we apply the speed. This is 0.025 speed. So when we use 0.05 and 0.075 will be the same equation but different data. So that's all for me. Thank you. Ooh.